In this video, we're going to solve applications involving using normal distributions to approximate binomial distributions. We talked a little bit about the continuity correction factor last time, which we'll need to use this time. So if we have a binomial distribution where n times p is greater than 5 and n times q is greater than 5, remember that q is equal to 1 minus p. Then we are able to do this approximation technique using the continuity correction factor that we talked about last time. So determine first whether you can use the normal distribution to approximate the binomial distribution that's given, and if you can, use the normal distribution to approximate the indicated probabilities and sketch their graphs. If you cannot, explain why and use the binomial distribution instead to find the indicated probabilities and identify any unusual events. So in a survey of US adults, 19% say they have participated in a clinical trial. That's my P right there. That's going to be 0.19. You randomly select 220 US adults. Find the probability that the number who have participated in the clinical trial is no fewer than 35, more than 44, between 39 and 49 inclusive. All right, so let's first see if 0.19 times 220 is 5. If this smaller number, because 1 minus 0.19 is bigger, if this number is bigger than 5, and it certainly is, then the other number, NQ, is also going to be bigger than 5. If the smaller number is too small, we're done. But we usually only have to test one side or the other here. So yes, both NP will be bigger than or equal to 5. And NQ will be bigger than or equal to 5. So let's say that our mean here in this distribution is going to be NP, which is going to be what we just found here, 41.8. And our standard deviation is going to be 0.19 times 0.81. So that's my N times my Q times my P of 0.19 here. I'm sorry, my N, NPQ. N is 220 times P times Q is, and let's round that to a couple of decimal places here, 5.82. And then we'll use that more exactly here when we get these numbers. Find the probability that those who have participated in the clinical trial is no fewer than 35. So X greater than or equal to 35, like that. So we're going to look at this continuity correction factor. 35 is on the left-hand side, so we're going to subtract 0.5. This is going to turn into a statement X greater than or equal to 34.5 for normal distribution. And so second distribution, normal CDF, lower bound of 34.5 up to positive infinity with a mean of 220 times 0.19 and standard deviation of the square root of 220 times 0.19 times 0.81. Close all that off. And to 4 decimal places, this is 0.8952. All right. Now, which graph looks correct here for the mean? Being 41.8, all of them have the mean of 41.8. We have greater than or equal to 34.5. That looks like this one right here. Now let's find the probability that the number who have participated in a trial is strictly more than 44. This is binomial, right? So this is going to be, normally 44 is the A that's on the left that we would subtract, but this is strictly less than, so we're going to add. So this is going to be X greater than 44.5, like that. And so second distribution, normal CDF, 44.5 unbounded on the right, and still have the same mean and standard deviation here. And this is going to be 0.3213. And we still have a greater than or equal to situation. 44.5 need to actually be a little bit to the right of 44. So there's the mean, there's 44, 44.5 is over here, so it's A. Now find the probability that the number of people who have participated in the trial between 39 and 49 inclusive. So between 39 and 49 inclusive, this is my binomial. That's going to change to a normal of subtract on the left and add to the right, like that. And second distribution, normal, 38.5, 49.5, same mean and standard deviation, 0.6218, and going to be a little hard to see with some of the writing that's over top here, but we want a between situation, and the only between is going to be this one right here. That is A, where we have 38.5, which is just a little bit to the left of 39, and 49.5, which is just a little bit to the right of 49. So any unusual events here, all of them appear to be above 5%, so there are no unusual events. Let's just verify. Yeah, all above 5%. That's it for this video. And that's it for chapter 5. So we'll come back next time and start talking about chapter 6. And I already mentioned that that has to do with confidence intervals. So see you for the chapter 6 topics next time.